Today we're going to talk about graphing a function rule. Today we're going to talk about graphing a function rule using a table, but there are other ways that you can graph certain function rules. For today we're only using a table because that works for any function rule that you would like to graph. So to graph a function rule today, we're going to make a table to find the ordered pairs. You're going to choose your input values or your x values, and you're going to plug them in to solve for y or get your output values. And then you are going to graph the ordered pairs that you created in your table. So the first question says, what is the graph of the function rule y equals negative 1/2 x plus 2? This is the one that I was talking about. You probably should know what this equation is going to be. It's an equation in slope-intercept form, y equals mx plus b, and we have another way to make this, to graph this function rule. However, today we're going to practice tables. So we're going to go ahead and make a table. And you'll notice that I've chosen my x values of -2, 0, 2, and 4. A couple of little tips or rules to choose your input values or your x values. First of all, you always want to make it as easy on yourself as you can. So if you notice, I'm multiplying by -1/2, your x by -1/2. That's the same as dividing by 2. So if you notice, I've just chosen even numbers so that my outputs will still be whole numbers. I also want to stress to you that it's going to be important in most situations where you're just given a function rule to graph that you choose both negative numbers, positive numbers, and go ahead and choose 0 for your input. 0 is usually going to be a really easy number to plug in, but you do want to include it in your table and in your graph. So let's go ahead and plug in these values. -2, when you plug in -2, you have -1/2 times -2, which would give you a +1, and +1 plus 2 is 3. 0 times anything is 0, and 0 plus 2 is 2. 2 times -1/2 would give you a -1, and -1 plus 2 is a +1. And then when you plug in 4, 4 times -1/2 would give you a -2. -2 plus 2 is 0. Next, what you're going to do is you're going to go ahead and plot the points. If you'll remember, the x-axis is the horizontal axis, so to plot the point -2, 3, you would go to the left 2 places from your origin, and then you're going to go up 3. To plot 0, 2, you would stay on the y-axis at the origin and then go up 2. 2, 1, you're going to go to the right 2 and up 1 from the origin, and 4, 0, you're going to go to the right 4, and you're going to stay there. You're not going to go up or down at all, and then go ahead and connect the points when you're just asked to graph the function rule. So this next example is a little bit more complicated. It says, what is a graph of y equals x squared minus 1? You might have graphed something like this before. Chances are you probably haven't, but if you notice, it says x squared. So it's not 2 times x, it's not x divided by 2. Those are the types of things that we are used to graphing so far. This is an x squared. The only way we know how to do this right now is to go ahead and make a table, plug in your x values, solve for y. Now, another thing that I want to talk about really quickly is choosing smart points. I talked about it a little bit on the last example. But if you start to choose something like 5 and 6 and 7, when you have to square those numbers, 5 squared is 25, right? And then you're only subtracting 1. So that means on one of your axes, and in this case your y-axis, you would have to go up to 24. You can count by 2s or count by 3s or something like that. That's going to make your graph look somewhat distorted if you don't do it on both axes. So I would suggest not doing that unless you have to. The other thing is you don't want to spend like a ton of time making a graph and counting to 25. So I've kept my numbers small, knowing that I'm going to square them. The other thing that I want to remind you of is when you're plugging in your inputs, you remember you always put them in parentheses, and that's important in this case because when we plug in -2 and we have to square it, the parentheses would tell us to repeat the negative. So -2, when we plug it in for x squared, would be -2 times -2, which is a +4, and 4 minus 1 is 3. Again, when you plug in negative 1 squared would be negative 1 times negative 1, which would be positive 1, and 1 minus 1 is 0. 0 squared is 0, and 0 minus 1 is negative 1. 1 squared is 1, and 1 minus 1 is 0. And then 2 squared is 4, and 4 minus 1 is 3. Go ahead and you would have to plot these points. Connect the points in the order that they were in your table. So if you're starting at negative 2, 3, you're going to connect that point to negative 1, 0, and then you're going to connect negative 1, 0 to 0, negative 1, and so on. This graph is called a parabola. Anytime you have x squared in a function, it's going to be called a parabola. So it is a little bit curved, right? It's not a straight line. It's not a straight graph at all. It's curved, and then it would keep going on. The graph of a real world situation should only show points that make sense. So let's talk about that with this next example. It says the function c equals 12.5h plus 30 represents the total cost of renting a truck for h hours. What is a reasonable graph for the function given the daily limit is 12 hours? So two things that aren't going to make sense here. First of all, because the limit is 12 hours, 12 should be the largest value we graph for h, right? You can't, it's not a possibility to keep it for 13 or 14 or 24 hours. You can only keep it for 12 hours, so let's only include numbers up to 12. The other thing that wouldn't make sense here that I said you should do earlier is negative numbers. You can't graph a negative, you can't rent a truck for a negative amount of time, right? That would mean that the company might owe you money for not renting a truck. It just does not make sense. You can't rent something for a negative amount of time. So for some reason, I decided to change my h and c to x and y, but my x's are what I'm plugging in for h. So I chose to include 0 to 12, and I just chose 4 points and spaced them evenly. So I chose the point 0, 4, 8, and 12. When you plug in 0, 0 times h is 0, plus 30 is 30. When you plug in 4, 4 times 12.5 is 50, and 50 plus 30 is 80. When you plug in 8, 8 times 12.5 would be 100, plus 30 is 130. And then when you plug in 12, 12.5 times 12 is 150, and 150 plus 30 is 180. Then you're going to go ahead and graph those points in a coordinate plane. Notice I only included the first quadrant in this graph because that's the only part of the graph that makes sense. On the horizontal axis, which should be labeled number of hours rented, I've only included 0 to 12. For the horizontal axis, or the y-axis, I've included 0 to 180. That's the largest value on my table, the largest value that you could owe for one day. This should be labeled the total cost. And then notice that I've counted on both axes by different increments. So on the vertical axis, I've actually counted by 18s. That's kind of random. You could have done 20s, 10s, 12s if you wanted to. I don't know. 15s maybe. But you do not have to tape pieces of graph paper together to get 180 little squares, right? You can count by different measures or different increments. And please do that because that just wastes a whole lot of time because you literally have to sit there and count the little squares to 180. Nobody has time for that. And then I've chosen on the horizontal axis, I did go ahead and count by 2s. You can count by 1s. That's not really that big of a deal. It's just preference on what you would prefer doing. The last thing we need to talk about is a continuous versus a discrete graph. A continuous graph is a graph that is unbroken. So this would be an example of a continuous graph, right? It's a solid line. It would keep going on forever and extending, and there's no point, like the whole line, everything is connected. A discrete graph is composed of distinct isolated points. So if you look at this one, notice I have different points on the graph, but they are not connected. So let's talk about a situation where discrete might make sense more than a continuous graph. It says Megan buys eggs at the supermarket for $1.75 per carton. The cost is a function of the number of cartons bought. What is the graph of the function? Is the function continuous or discrete? So if you think about a normal supermarket, right? You go and now they actually sell things of 6 eggs too. Not sure if you know that. They do. But we're talking about like a supermarket. They just have a dozen eggs for $1.75. You can buy 1 carton or 2 cartons or 3 cartons, but you can't just randomly buy 15 eggs, right? You have to either buy 12 or 24 or 36. You have to buy them by the dozen. So this function is actually going to be discrete because you have to buy a whole carton. You can't just take a certain amount of eggs from a carton and pay the difference or pay that ratio of the carton cost to how many eggs that you have. So X is going to be my number of cartons and Y is going to be the price that you owe. I just said 0, 1, 2, 3. Negative cartons, again, wouldn't make sense here, so I don't need to include negatives. If you buy 0 cartons, right, you're going to owe $0. You didn't buy any. You don't owe anything for eggs. If you buy 1 carton, that would cost you $1.75. If you bought 2 cartons, that would cost you $3.50. And if you buy 3 cartons, that's going to cost you $5.25. So when you make this graph, this is going to be a discrete graph because the points, like you can't buy a 3/4 of a carton of eggs or 1.1 carton of eggs. Now, sticking with the supermarket or the grocery store theme, something like apples that you buy by the pound, right? Like if there's just a whole bunch of apples out and you put them in your own bag, they're not pre-packaged at all. That would actually be continuous, right? Because it's priced based off of pounds, and you could buy 1 pound, 1.1 pounds, 1.2 pounds, 1.3 pounds, and so on. So I just wanted to say that you have to kind of think about that. So this one would be discrete because it's per carton. But things like apples maybe wouldn't be discrete because it would be continuous because you get to choose how much, and there's a lot of different possibilities for how many pounds of that you're buying.